Alright, so how does the clipper circuit work? Well, the circuit is actually very simple. Suppose I have a wave like this. I have a wave like this. Suppose I draw a simple sinusoidal wave, but the fact is that the input wave to a clipper circuit does not need to be sinusoidal. Okay, it can be a signal of any type. Okay, so I can suppose that this signal is within the range of plus 10 volt to minus 10 volt. Okay, yeah. So I suppose want to limit this signal to plus 5 volt. This is the plus 5 volt mark, that no voltage greater than 5 volt can come to the output, can remain in this signal. Okay, so how can we do this task? The circuit that can do this task looks like this. Okay, I have my sinusoidal voltage, or this can be any type of signal, not necessarily sinusoidal. I have a resistor. Okay, then I will draw a diode. So in this case, what we want is that we want all voltages below 5 volt to pass. Okay, all voltages below 5 volt to remain as it is, but no voltage greater than 5 volt can pass. All voltages below 5 volt will be able to pass. So notice this direction of the arrow. In this the direction that we drew in this graph, we will draw our diode in that direction. Okay, we will draw our diode mimicking the direction of the arrow. All right, then we will draw a voltage source. Suppose I draw basically a battery or a voltage source like this, and what is the value of the voltage that I want to limit this signal to? Well, the value of the voltage is 5 volts, so I will use a voltage source of 5 volt. Okay, so this is the circuit. What is the input port of this circuit? Our input port is this is our input signal, and output port is this is our output signal. Okay, so how does this circuit actually work? Why does this circuit limit this signal? We will explain that in a supplementary video. Okay, so since your exams are nearer, your exams won't tell you to explain how a clipper circuit works. You will basically have to design a clipper circuit for a specific task. Okay, so the recipe for designing a clipper circuit is this. Suppose I want to find a circuit, I want to design a circuit that will pass all voltages below 5 volt. So I will give this resistance. This resistance can be of any value. Okay, the value of this resistance does not have to be anything specific. I can use a resistance of 1k or 2k or 100 ohm or any resistance you wish. Basically there will be a resistance here. I want to pass all signals below 5 volt. Since I want to pass all signals below 5 volt, I will draw the diode in the below direction or in the downward direction. Okay, I will match the direction of this arrow to this diode, and then I will draw a voltage source and give the value of the voltage that I want to limit the signal to. Okay, so in the same using the same signal. Okay, suppose I have this signal. Oops, sorry. Yeah, I have this signal and I input this signal to a circuit like this. Let me show you. Suppose I have a circuit like this. voltage source here, and the value of this voltage source is 2 volt. Okay, and I take the output of this circuit from these two terminals as before. What will the output look like? Okay, so to draw the output, let me just copy this signal. Yeah, so I input this signal from plus 10 volt to minus 10 volt and input this signal to this circuit. Okay, to this circuit. So since the diode is in the downward direction, no voltage below 2 volt can pass. Alright, let me just erase this. No voltage below 2 volt will pass. So what is the 2 volt voltage level? The 2 volt voltage level is, suppose here, this is our 2 volt voltage level. Okay, so what will the output graph look like? So the output will first rise up to 2 volt. This is the 2 volt level. Then no voltage above 2 volt will be allowed to pass. Okay, the voltage will be clipped at 2 volt, and all voltages below 2 volt can pass. So all voltages below 2 volt will pass. Then it will again rise again. Then again it will be clipped at 2 volt. Okay, and it will continue. All right, so yeah, that was simple. That if you want to clip your signal at 2 volt, you will use this circuit. What if I drew a circuit like this? Okay, let's see. What if I drew the circuit like this? In place of 2 volt, I give here minus 2 volt. What would happen? So in this case, all voltages below minus 2 volt would be allowed to pass. All right. So what will the output look like? The output will look like this. Okay, so the output will look like, first we have to find the minus 2 level. The minus 2 is, suppose, at this place. Okay, so all voltages, remember what is the direction of the diode? The diode is pointing downwards. Okay, so all voltages downwards of minus 2 volt can pass. So if this is minus 2 volt, then this part of the voltage, this part of the input signal will pass as it is. And what will happen to voltages greater than minus 2 volt? Well, they will be clipped as before. So this blue graph is the output of this circuit. Okay, so you will just look at the direction of the diode. This diode says that all voltages below 2 volt will pass. So all voltages below 2 volt are passing. And this circuit says that all voltages below minus 2 volt will pass. So all voltages below minus 2 volt are passing. Now suppose I want to design a circuit that all voltages above 2 volt will pass. What will that circuit look like? Well, heuristically, we can just draw the circuit like this. Okay, the circuit will be like this. What do we want? We want that all voltages above 2 volt will pass. So our input will be our sinusoidal signal as before. We will draw a resistance and we will draw a diode. Now we want all signals above above 2 volt to pass. Okay, so we will draw the diode in the above direction or in the upward direction. Okay, as before, we will draw a voltage source and give the value of the voltage source. The value of the voltage source will be 2 volt. Okay, so what will be the output of this circuit? If I input this input signal to the output to this circuit, what will be the output? Let me draw it again. Yeah, so first we'll have to find the -2 voltage level. Just copy this signal. Yeah, let me just keep this signal in the side so that I can copy it later. Alright, so first we will find the -2 voltage level, sorry, +2 voltage level. So this is the +2 voltage mark, I suppose. Now all voltages above +2 will pass. Okay, so this voltage above the +2 mark will pass as it is, and I have also this part, this voltage above the +2 mark will pass as it is, and all voltages below 2 volt will be clipped. Okay, so it will become a straight line. Alright, yeah, simple as that. What would happen if I release this 2 volt with a -2 volt? Can you guess? Well, let me draw it here. Okay, well, for clarity's sake I can just draw the circuit again. Okay, clearly remember what is the output port of our circuit. These two ports are the outputs. Okay, so if I put -2 volt here, then the diode direction means, since the diode is pointing upwards, it means that all voltage upwards of -2 volt will be allowed to pass to the output. Alright, so suppose this is the -2 volt mark. Okay, what voltages are upwards of -2? Well, almost everything is upwards of -2. All these voltages, the part that I am drawing in the blue graph, using the blue pen, all these voltages will pass to the output as it is in the input. Okay, and all voltages below -2 volt will be clipped. Alright, simple as that. Okay, so just by seeing the direction of the diode and the polarity of the voltage, you can see that at which level will the input signal be clipped, and what part of the input signal will pass.